Good evening and welcome back to the class. Today we want to look at circle geometry. So first we need to understand the properties of a circle. First, we want to look at this. This is the circle. We all know this shape called circle. And when we have a circle, we have a chord. A chord is a line segment that touches the circle at 2 points on its circumference. A line segment joining the circle at 2 points on its circumference. So what we have here is diameter. Diameter, for the fact that diameter is a line, it is also a chord, but it's a special chord because this particular chord runs through the center of the circle. So this shows that this is the center of the circle. So that line there is called the diameter of the circle. And the line that runs from the center to any point on the circumference is called radius. Now, once we have a chord divides a circle into two segments, the major segment and the minor segment. Major segment because it is bigger in size, minor segment because it is smaller in size. So the shaded part is the major segment here. We also have what we call the sector of a circle. You can see this is just the sector of a circle. It's the one I cut out using a cardboard model. So this one now, from the center, I have cut out a part of the circle. So this is a sector. This is also a sector. This is the major sector, the minor sector. We also will have what we call an arc. As long as it is not closed, it remains an arc, no matter how close they may be. And no matter how small it is also an arc of a circle. So these are the basics we need to know before we go into the circle geometry proper. So the first theorem we'll be looking at is the theorem that says that the angle that the chord of a circle subtends at the center is twice that which it subtends at any other point on the circumference. I repeat, the angle that the chord of a circle subtends at the center is twice that which it subtends at any other point on the circumference. Just know this and notice that when you have a circle and you have angles within that circle, whichever one is subtended at the center doubles the one that is subtended at any other point on the circumference of that circle, like we have here. So these angles are subtended by this chord. The chord is not shown, but this is the chord subtending these angles. So if we have 2x here, we are simply going to have x here because this one is twice what we have here. So if we have 1 here, we're going to have 2 here. If we have 2 here, we're going to have 4 here. Or this one is the double of what we have here. Now that means that since here, if here is 84 degrees, the angle we have here will now be 84 divided by 2, which is 42 degrees. That's the application of the theorem we have. Here we also have this circle with these angles like this. This is the angle at the center, which is M. So M is supposed to be twice of what we have at the circumference. Remember we said any point on the circumference. So this is 2 times 68, and that will give us 136 degrees. So that's it about angles at the center and angles subtended at the center and angles subtended at the circumference. We move to the next theorem. The second theorem we'll be looking at is a theorem that says that angles in the same segment of a circle are equal. Angles in the same segment of a circle are equal. Okay, let's see. We have this. We may not bother for the proof because mathematics is moving from the area of proof to application. So we are saying that angles in the same segment are equal. Angles in the same segment of a circle are equal. So let's have these circles. What we're saying is this, that if the angle here is x and the one here is y, we are saying that x should be equal to y because they are what? In the same segment. You can see they are in the major segment of this circle. So whatever I have here is what I'll have here. And even if I have a third one here, which I may label z, x should be equal to y, which should also be equal to z. And we move to the next theorem. Okay, let's do a little work here. And we're now saying, for instance, if what I have here is 70 degrees, I am saying, and maybe this one is M, I am saying that M should also be 70 degrees. The reason is that they are in the same segment. Okay, we move to the next theorem. The next theorem says angle in a semicircle is a right angle. Theorem 3 says angles in a semicircle, that angle in a semicircle is right angle, or is 90 degrees. Now we have this. Let this be the diameter. So it means that here is the center of the circle. So we are trying to say that the angle here is 90 degrees. Why is it so? Remember the first theorem we talked about says that angle subtended at the center of the circle is twice the angle subtended at any point on the circumference. You and I know that angle on a straight line is 180 degrees. So this one now is subtended at the center, while this is subtended at the circumference, which means here will now be half of 180, which is 90 degrees. And let's see some worked examples based on these theorems we have listed here. Let's see how complicated our diagrams could be, and we should be able to sort them out.